5 of my course on machine learning, data preprocessing for machine learning. This particular course is brought to you by my YouTube channel AINEXUS. Please do subscribe to it. I am Dr. T.V. Geeta. This is a playlist course on machine learning. It will contain all these videos. Now let's look at the learning objectives. You must first understand what you mean by data and features, the importance of data preprocessing, different methods of data collection, and then missing and inconsistent data, feature coding, encoding and feature scaling methods, feature engineering concepts, and the complete pipeline. So before we go into data preprocessing, let us talk about data points and features. So let's take a small toy example of the data set table. Here each row is a data point, one observed sample with all its feature values. For example, DB3 or data point 3 here has 20, 90 and 25 as its feature values. The column is the feature. What feature? Describe what we measure, like temperature, humidity and wind speed. Now, why do data points matter? The more the data points is better the learning. Each data point helps us to understand the patterns in the data. And why do the number of features matter? Better features means you get better accuracy. So here one data point is weather conditions at one point of time, and features are the measurable weather properties. From a mathematical viewpoint, a data point is written as a vector. X is equal to x1, x2, x3 and so on, where each xi is a feature. So here if you take the ML task mapping, features are temperature, humidity and wind speed, and the label is rain. You want to predict whether there is rain or not, yes or no. So here is the mathematical viewpoint, how you talk about it, where x is one data point. And there are types of features. It can be numerical, it can be categorical, like city, Delhi, Kochi, Chennai. It can be binary, it can be text, it can be image, pixel values, it can be time based, it can be audio, it can be location like latitude, longitude, and so on. Now let's go to data preprocessing. So machine learning models learn from data. So poor data, including before data preprocessing, is poor model performance. So if you have raw data, incomplete, inconsistent or noisy, if you clean it, then you get a better model, a machine learning model, higher accuracy and reliable results. So why do you need to do this data preprocessing? Real world data is often incomplete, inconsistent, noisy. And machine learning to work well with better accuracy, you require clean and structured data. Okay. So data preprocessing often consumes 60 to 80% of a typical machine learning project effort. So importance lies in for data preprocessing lies is improving the accuracy, removing inconsistency, reducing noise, speeds up model training, and improves the model reliability. Now the pipeline is you have raw data, you do the data collection, data cleaning, missing value handling, feature engineering, feature scaling, feature encoding and engineering, prepared data set you have, then you have the split of the data set, and then finally you give it to the model. The benefits is better model performance, faster training, improved prediction accuracy and reduced bias. So this is the data pre-processing pipeline. Now, what is data collection? The process of gathering data from different sources is data collection. So, the sources can be databases, CSV or Excel files, sensors, IoT devices, APIs, websites like web scraping, surveys, social media. From hospital, for example, it can collect patient age, blood pressure, sugar level, diagnosis. That is another type of data. And you can have structured data, tables, databases, Excel sheets, unstructured data, images, videos, audio, emails, documents, and semi-structured data like JSON, XML, HTML. So good data collection is the foundation of accurate analysis and better decision making. So data cleaning, what is data cleaning? Removing or correcting errors in a data set. So you can have common problems are missing values, duplicate records or incorrect values. Inconsistent formats also could be there. Outliers may be there, and typographical errors could also be there. So you have to take the dirty data and produce clean data. So the first we talk about is handling missing values. What are missing values? They occur when information is unavailable. It could be data entry error, sensor failure, survey non-response, lost records. And for example, is given here, you can see there are two entries that are missing. Most machine learning algorithms cannot process missing value, data directly. So you have to do handle this. So techniques are removing the missing records at all, or fill the that particular missing value with the mean value, or fill it with the median, or fill it with mode, that is used for categorical data, or you can use ML models to predict the missing values also. So pandas example for this is, you import the pandas library and then read the CSV file into a data frame. Then there are some inbuilt libraries that inbuilt functions that help you. So df dot is null is to detect missing or null value. Df drop NA method in pandas is used to remove missing values NA and non null from a data frame. Fill all missing values with numeric. Average mean also can be done, or replace all missing values with a frequent value, that is a mode, also can be done. So these are the important functions that are used in handling missing values by pandas. Now removing duplicates, example, you have two entries here with name Alice and ID. So this duplicate rows can bias the model, increase the training time, distort statistics. So you have a pandas function for that. We have drop duplicates. Then encoding categorical data. Machine learning algorithms require numerical data. So if you have an example, color red, blue, green, it cannot be directly processed by machine learning. So you need encoding. So there are a lot of encoding techniques. One is label encoding. So you have red, blue, green. You convert each category into an integer. Or one hot encoding, where each column, it's a new binary column for each of the categories. So only one column is one, the rest are set to 0. Okay, so label encoding normally for ordinal categories and one hot for nominal. What is the meaning of nominal? No order. Ordinal, ordered. Example, nominal is red, green and blue. Ordinal is small, medium, large. So this encoding converts categorical data into uh, numerical or some data that ML models can understand. Then is feature scaling. Why scale features? Different features may have different ranges. Different features often have different ranges. So example, you could have age in this way and salary in this way. So the range here for age is 18 to 60, but for salary it's this. So large value features can dominate the model learning. So scaling makes features comparable, and the benefits are that faster convergence, better accuracy and fair comparison. Right, there are many methods of feature scaling. For example, standardization, this is called the set score. Transform data to have a mean of 0 and standard deviation of 1. So best for certain algorithms like SVM and PCA. Then you have min-max scaling, which is normalization. Scales features to a fixed range, usually between 0 to 1. Is bet for neural network type of algorithms. And maximum absolute scaling is also given here, dividing the max by maximum absolute value. This basically deals with outliers. And robust scaling, x minus median by IQR, where IQR is the interquartile range, and this is less affected by outliers. So choosing the right scaling technique based on your data and the algorithm you use, that is very important. Then you go to feature engineering. What is feature engineering? Creating new useful features from existing data to improve the model performance. So instead of using age directly, you can use age group. Instead of day, month, year, you can use date. Instead of salary category, you can use Instead of salary, you can use salary category, and instead of height and weight, you can use BMI. The benefits is improves prediction accuracy, captures hidden relations. Often, the person with domain knowledge can do this very well. So it captures hidden relationships and reduce this complexity. There are other techniques also by combining variables, splitting variables, and so on. Not all features are useful, so you can even have feature selection by filter methods, wrap methods, and all. This also benefits by giving rise to faster training, reducing overfitting, and improving interpret. Data splitting, this is important in any machine learning algorithm. So you split the data into training set, validation set, this is optional, and test set. The typical ratio used is 70% for training, 15% for validation, and 15% for testing. If you are not using validation, then it's 80% for training and 20% for splitting. The purpose is to train the model. You learn the patterns from the training data. Tune the hyperparameters, you use the validation, and evaluation, you use the testing. So why it matters? Proper data splitting helps build robust models and generalize well to new unseen data. So this is a hands-on example using uh, our Python. So you load the data and then you handle the missing values. Here mostly it is using pandas. Then remove the duplicates, then encode the categorical data. So you have methods to do that, and then scale the features. So most of this is provided. How to do this? Functions are provided. And the key takeaways are data pre-processing is a critical step. Should be collected, cleaned, and missing values and duplicates handled. Feature encoding, scaling, and engineering and feature selection is important. And pre-processing pipeline with all this is gives rise to a better machine learning model. So let's look at a suggested demonstration that can be used using the available functions. So detecting, you can use either the Titan data set or the Iris data set, both are available free. So detecting missing values, filling missing entries, applying label encoding and one-hot encoding, scaling numerical features using standard scaler, and creating a new feature. For example, you can create family size for Titan. It's up to you. So this hands-on example helps students see the complete pre-processing workflow. So this can be demonstrated. Now, here I give you the references and the exercises. This is for understanding. I've given you some problems also for this data pre-processing and some mini projects that you can do. I have not used the other two, so student performance and so on. Customer churn data processing, heart disease data preparation, all these data sets are available. Okay, so thank you for listening to this video. The fifth video on my playlist, Course on Machine Learning. This is brought to you by my YouTube channel, AINEXUS. And the next video, we'll be talking a little more about data, which is exploratory data analysis and data visualization. Thank you.